So I'm Yashwanth Singh from Bosch. So today's talk is about unleashing the power of RISC-V with TrusteD-V. So we have built the entire Rust RISC-V software ecosystem. Before that, let me introduce about myself. So I am a silicon and security architect in Bosch. I had a team of RISC-V software innovation guys. Right now, we are trying to build a RISC-V startup, which is Bosch startup, which is completely focused on software innovation. Yeah, before this is a table of contents. So I'll talk about challenges what we faced. So why did we use Rust and RISC-V? Identify RISC-V startup software stack, TrusteD-V product suite. How do we board bring up the RISC-V chips? Then lastly, I'll speak about how you can do board bring up in like 5 minutes. Then at the end, we will also discuss about the RISC-V Rust IDE. So in Bosch 3 years back, we were when there was a hype going on about RISC-V. We tried to take all the RISC-V chips across the globe, India, Europe, and USA. While porting our production grade software into RISC-V, we found a lot of gaps. The first challenge is the scarcity of design. We know that ARM has something like ARM M4, M1, M7. So we especially use NXP and Infineon family of chips to in our ECUs, etc. We found a gap that everybody is building RISC-V chip, but there's no reference design. In India, people use Shakti sometimes to take a reference core. Someone in USA building some other reference core. So there was a lot of gap. And also there was a lot of immature tool chains and proprietary tool chains. So sometimes just to do board bring up activity, it used to take from months to 2 months. Usually it should be around 1 or 2 weeks. Solving these two issues, the one more issue was portability challenges, portability issues. For example, if you're trying to port the whole software onto one RISC-V core built in one of the company and trying to port it on another RISC-V core, again, there were a lot of issues because vendor used to add some vendor-specific add-ons to it. If you have solved all 3 issues, then the final issue is the reliability and trust. A company, someone who is trying to build a RISC-V core, and we try to take their chip. If the company is gone, how do we manufacture the ECUs in the market? So these were the questions in our head. Should we really go for RISC-V family of chips from the new age guys? If we are taking it, how do we proceed? That is when we built something called TrusteD-V. TrusteD-V is also called as Trusted RISC-V. You can call it a RISC-V ecosystem, or it's a framework, SDK, everything, which I will tell about in detail. So we decided to build the entire software stack, for RISC-V. Then there was also which language to choose. So Rust was a popular choice from among us. Why? Because Rust has already taken over 25% of market share, and because of its safety and performance, it's entered into IoT, embedded and automotive market. Why should be Rust should be a program of choice in RISC-V? Because of its memory safety, concurrency. The time to market reduces from years to months. One thing. Second thing is anyway you're building everything from scratch. Why not we go for Rust, the entire middleware, etc. And the third thing is the Rust's modularity and RISC-V's design together, a combination could pave a new era of innovation where safety and security would be a base of it. So keeping this in our mind, we started to implement the entire middleware stack, everything in Rust. This is how at the highest level this architecture looks like. So any hardware, it could be GPU, CPU, NPU, TPU, or any RISC-V core which is built from a RISC-V core. So we're going to give the entire stack, middleware stack. It could be the OS stack, it could be the trusted hardware stack, or it could be secure bootloaders. So we're going to be providing the middleware stack, also the RISC-V tools. So we have primarily focused on the middleware and the tools. This was the initial idea 3 years back, and then it paved into building these many things. So we actually build something complete middleware stack from bootloader to OS, and then details chip-specific SDK and compatible layers. I'll tell you how we have a demo how it can be used here, and also secure trusted bootloaders and trusted drivers. We also added support to real-time OSs like Hubris, Stock OS, Embassy, etc. Integrated tools like ProBaris, secure booting, debuggers, and flashing utilities. Everything was added. We also built an IDE specialized for RISC-V. It's called RISC-V Rust IDE. And we also gave a marketplace where any chip company who is building RISC-V core can come to us, and they can, using TrusteD-V, you can enter the Bosch world. So this is the SDK. So whatever I have built, it's not public yet. It's going to become public in February. This is how the suite looks like. You're going to get secure bootloader, trusted HAL, certified RISC-V tool chains, secure microkernels, RISC-V compiler, and RISC-V, compiler is one of the project where we're going to make a SIG group and we're going to make a open source project, LLM integration, and we also built IDEs, tool chains. You also get SDK ecosystem and also accelerator SDKs. Any company is building some kind of accelerators, we have a patchwork to have the APIs to it. So how it's going to work is, so any company who is trying to build a RISC-V hardware, they just have to put their SDKs and SPD file into our RISC-V server. It generates the entire middleware stack for you, and detailed spec will be given out to you. Any company, example, if you want to build a smartwatch, you just have to write a prompt telling that I want to build a smartwatch. So it generates the middleware for you. It could be there are three ways to use the solution. One is a prompt base. You can write a prompt, or you can select discrete components. You can select one chip from one RISC-V company, other chip from other company, and the middleware will be generated for you based on that. Then automatic board bring up happens. At the end, you get API keys to access the hardware. So yeah. So I have a quick demo how the entire solution looks like. This is actually not public. This is going to become public in next 2 to 3 months. This is how the entire platform looks like. It's called TrusteD-V. TrusteD-V stands for Trusted RISC-V. Yeah. This is a product suite. Explain the product suite. So let's go into hardware catalog. So any company, there are 600 startups have collaborated with us. So all the chips specifications about these startups will be available in our thing. Or there are some open source chips, we added support to it. Let's get into one of the chip, Micro Vision SoC. Details about each chip will be provided. This is by from the vendor itself. They will be putting all information about it, product description, specification, etc. You also get documentation about these chips. So which architecture, memory, I/O is being used. So whatever information about the chip you need to put into our ecosystem. And then documentation will be available, which has PDF, which has data sheet, reference manual, etc. And the partner information is something at the end where who is built this startup. So how do you add this chip into our ecosystem is, this is the next thing we'll be showing it. So there's a place called become a partner. Anybody who's building a RISC-V chip can become a partner to us. So they just have to join the RISC-V ecosystem. They have to write the company information, what they are building, which chip they are building. And once you fill all these things, it goes to a next page where whichever chips you're trying to build, example, you're trying to build an accelerator, about the detailed spec you have to put into this. So then in the backend, the entire code will get generated, the middleware stack will generate for you. So once you add the chip, it comes to this page, like here. Then next step is you have to build a solution. Now we have to build a solution. Yeah, there are some example projects what we have built, like IoT sensor network, Edge AI chip, etc. So if you go inside this, you will find which chip is being used, what is the software, etc. like that. I'll show you how to build a project using this thing. Let's go to a chip builder solution. You can either prompt a solution, or you can select a board, or you can use the discrete chips. Okay. So let's go one by one. First is prompting. So we have some example projects like smart LED controller, environment monitor, and QSPI-based data logger. Okay. Let's take one of the example RPI-based RISC-V telemetry thing. So once you press this, you can also write the prompt. So the prompt gets out. From this, you will get the application layer, the middleware, and also the which chip is being used, RISC-V core is used, and the hubris OS gets selected. And then the next step is you will get the hardware BOM and software BOM. So all the layer from the backend, it gets generated for you. And which peripherals being used, UART and GPIOs. You get the hardware BOM, which chip is being used, and what is the cost of it. Which in the software BOM you'll get which LAL is being used. Second thing is you also can use existing development board, whichever development board is there. From that you can choose, and you can also do the same thing. I will show example where we will do using the discrete components. Same thing happens for your case. The entire middleware comes out for you, and the hardware BOM and software BOM comes out. And if you click that button, you get the SDK downloaded for you. Let's go last page. This is where you can select. You can select one of the chip, Micro RISC-V. You can select the OS, embassy, and whichever UART peripherals you want, like GPIO, UART, and you just generate the plus button, generate. It generates the entire stack for you. Now the RISC-V ID opens up. So you will get everything inside. The entire boilerplate codes comes to you. You don't have to do anything. In the 2 minutes you did the board bring up activity. Now you can just write. From here you can do whatever modifications you want. Right now you have a OS here. I'm just modifying it to, let's do RISC-V 725. So you get entire project structure, whatever you wanted to build. You also, actually this is not a US code, this is a RISC-V Rust ID what we have built. So you get different structures like linker files, member.txt file, etc. So, and you can just press compile button to compile and build a project. Usually you have to write a lot of scripts, right? When you download this IDE, everything comes for you. That you also get a small place where ask model. If you want to add, for example, you have one UART1 is being used. If you want to add UART2 in it, you can just write that I want UART2 in my SDK. It just comes out from the RISC-V server in the Bangalore office. So you can just write a prompt here telling generate a code for it, generate embassy code which is for UART2, and you will get an option there where it generates a code for you from the backend. So there is no something like ChatGPT is being used. There is a LLM we have trained completely for RISC-V, which is hosted in a server. So those things comes out here. You get an option to accept or reject. Yeah. So now you can just press the button to flash the code on a thing. If you do, yeah, you're able to see the output. So the entire board bring up activity for any chip is being, if you just become a partner to in its tool chain, right? It did everything in 5 minutes. The entire board bring up activity happened in 5 minutes. So you're able to do the yeah. So next thing is RISC-V ID. So RISC-V ID is something which we have built. So traditionally you can use VS Code, right? So we wanted to add all the all the plugins into it in our IDE. So we built a RISC-V ID completely in Rust. This is how it looks like. You have a section where on the left side you get a project structure, and then below that you have a register files. Which register you can do debugging register by register, and also you have the interface where you can write the Rust code there. It can be C as well. And then you also get a terminal there where you can do the terminal debugging, etc. So this is IDE is specialized for the RISC-V family of chips. And you also get a ask model there. So whatever you want to, for example, you have written a project structure, you want to add something like a UART or SPI, you can just prompt it, and the code will come from the RISC-V server what we have in the Bangalore office. So any company who is trying to be a partner with us, so what happens is when they put the spec of their chip, right? So we will have one server dedicatedly which is having their code. So from their code base, you get the code here. So there's nothing. It is directly from there it is coming. The code is not going out somewhere anywhere else. Yeah. Summary is we have automated the entire RISC-V software toolchain, and you get the entire SDK. Now you get APIs, and you can just do the application level coding. Yeah, so I would like to end with this thing. So we are fully focused on RISC-V software and toolchain. What we do is we help startups to scale to the market. With us, you get a wider market. You get a lot of you get a lot of partners who are working with us. We suggest you with this chip can be used. So with us, you can all the semiconductor space will be democratized. Now it's going to be many players coming with us, and it becomes an ecosystem where RISC-V chips can be sold from us, and also we will be adding a trusted partner with you. Also providing a reliable and trusted one-step solution. So we will be also doing real-time testing of the chips, etc. All the results will be available. These results will go back to the startup, and they can improvise the chip. So these are the things what sets us apart. So I would like to end the thing telling let's take the risk out of RISC-V using TrusteD-V. You have my email address there. Anything, you can contact me on this thing. Yeah.
So I have a question about your AI that you use to create the configurations on the website. Does that pick from a standard set of configs, or does it actually do it on the fly? And if so, what guards do you have that it produces?
Initially, it does. It takes the boilerplate code from a master code, and then if you want to modify something, it does on the fly.
but I mean it's in the one where you describe the situation you want, and then it picks out the controllers.
Yeah, it picks out on the globe.
Okay, thank you.
So LLM is actually specialized in training. It completely trained on Rust and RISC-V. It is getting trained every single time. So we train the every single files like Augur or Toml is being trained for everything.